Okay.
Yes.
So good evening all of you. Today, today we are going to discuss how to install and work with Cara. So just first you just go to your Google and type Cara NMR download. So this will direct you to home page of Cara. Click on that and go to the Cara downloads page. So here you will get the latest version of the Cara for different operating system. So I'm using Windows, so I'll be download the latest version for Windows. So this you can save this to a folder desktop. So now you have to extract this file.
Download. Still downloading.
Okay, where is your Cara?
Okay. Nice. Yes.
To downloading Cara, just double click to open Cara. So here every you'll see uh, different options. So here there is no project loader till now, so there is no residue types defined. There are no scripts for Cara, and spectrum types, nothing is defined. So you need to have a repository or a Cara template, so that you can download from the Cara download page. So you can go to Cara templates. This is known as Cara template or Cara repository. So here, depending on what system you are working with, you have to download that particular template. So here it's option for protein liquid state, NMR, nucleic acid, and protein solid state. So I'm working with protein liquid state, so I'll download that template. So now you have to rename the template first. You downloaded template, it will be named as like protein liquid state some number dot Cara. So you have to rename it as your protein name which you are working with, which is any name you can give. Suppose you can give your name as well. So whatever you are doing with your data, it will be updated onto this template.
Also, I will take sequence.
So now you have to start a new project. Sorry, you have to open a new template, new from template. So click on the template. So after loading template, you will see that many things are defined in the Cara. So residue types are defined, scripts are defined, spectrum types are defined. All these are defined for a solution state NMR data. So to this template, you have to start a new project so that whatever actions you do, will be loaded on this template. So without starting the project, we can open a spectrum directly, or 2D spectrum directly by using tools and open spectrum. That will be opening in the monoscope. So there are different scopes to view spectrum in Cara. So without starting project, you can, if you just want to observe a spectrum with a peak list, you can open it in monoscope. So otherwise, for the assignment process, you have to uh, go with start a new project. So project, new project, you have to give a name for your new project. So I'm giving my name. Okay. So then it will ask, do you want to import a sequence? So press yes and import a sequence. So this has to be in a 3-letter format, like, so after loading the sequence, you will see your sequence is defined with labeling. So now you have to load spectra. So resonance assignment is making a map between spectra and the sequence. So now we need to have spectra. So right click on this white space and click on add spectrum. So there will be lot of spectrum types to be shown. So select 2D HSQC 15N. So that is a regular HSQC. So that's the point where we start the resonance assignment. So here my HSQC, I'm selecting, open the folder and click on. So if you have it in .param or UCSF format, it will appear, but if it is direct Brooker file, you have to click on 2RR type. So you will be opening one 2RR file. It will be added to the Cara. So in order to avoid confusions later, first itself you have to rename the spectrum. So I'm naming it as HSQC dot 2RR. Okay. So now you have to add all other spectrum. So I'm adding only one 3D spectrum. For assignment you need basically three 3D spectrums. One is HNCO, HNCSCB, CBCACUNH. So here I am demonstrating one 3D spectrum, which is
HHP CONH. Yes.
here. This one you have to define. Last time we defined,
We defined.
right?
Yes, we defined last
We
time.
defined. So here the spectrum I want to add is not there. So I will be defining a new type of spectrum. So go to spectrum types, click somewhere, add type. So give a unique name.
Here we added access.
Yeah, we have to copy that.
Yes.
What's the spectrum name? 3D HN HA
HBHA CONH.
HB HA
CO.
CONH.
Yes.
Correct. So we have to define the atom type.
H1. It's a HNH form.
Okay. So you have to define the atom and dimension type. So now you have to add label. Okay. Add label. depending on your.
HA.
Okay, now your spectrum type is defined. Go to file and save this Cara.
Desktop.
In that you can give a new name. Okay, so you go to spectrum, add spectrum, 3D, HN.
HHBCONH.
Okay, you save this and just start once again in case it is not showing up.
Yes.
Okay,
70.
so you can add that also. HA. Okay, now you can open your HSQC in different scopes are there. So for assignment we use syngroscope. So in syngroscope, so your HSQC will be open. So here you can zoom in and zoom out. By zoom in by control shift and drag one region, that will be zoomed that particular region. For zooming out, you can use arrow keys up and down, side and control shift and use arrow keys, or else right click and show fit window. Okay, so this is for zooming. Now we want to change the contour parameter type CP. CP is for contour parameter. So this is we have to give a value which is more suitable to you. So CP is for contour parameters. You can change the colors also. That is OP or T. So there are different options for the
Color.
color changing, all those things. Uh, okay, so you can change the views as well, peak shape. There are different commands for this. You can just explore in the options given to you. Now you have to pick a system. Pick a system means this is your HSQC. So for each peak in this HSQC, you have to need to have a label in the sequence. So in order to give a marker for the peak, you are picking a system. So I am selecting one region like this. In this region, I have 1, 2, 3, 4, 5, 6 peaks. So here I am picking peaks. So along x-axis as well as y-axis, you will see a peak. So you have to adjust your peak position to center of maximum of the two peaks. Okay, then right click on that peak and select peak system. So your system number 1 is selected and do it for all the other peaks. Okay, peak system, peak system like this. So you have selected 6 peaks here, so you have many other peaks in the spectrum, so that also you can pick. Now you have to pick the peaks in the 3D plane for the 3D experiment. Okay, so select the spectrum, which only one I have added here, so one option will come. If you add many options can come. So I selected my spectrum. So here I am getting one spectrum and its contour is different. So in order to change the contour, go to strips, set contour parameters, type a suitable contour for you, strips contour parameters.
Maybe side chains.
So you have to peaks in somewhere. In peaks are coming. Peak system. Okay, so you can change the width of the peak by right clicking on the side pane. Okay, now you have this particular peak level. So now we have to select the peaks for this. So by chemical shift, you know that this particular value 4.369 is HA values. HPK comes little lower, like 1.86 that range. So peak level HB this one. Okay, now you can see that. So this other the two panels in the side is actually the 3D plane for a peak. So this is 2D contour, and if you imagine a vertical line, that will be this one. Okay, now zoom the spectrum, zoom the particular peak, center it properly. Now go to the show 3D plane option by right clicking on that. So your peak center in the 3D plane will be somewhere different. Adjust it. So now your HA and HB chemical shift will be here. You can see. So for this particular peak, I have selected HA and HB. Okay. Now like this, you can do it for every spectrum and every peak. So every system will have a peak in the 3D plane. So that you have to pick. So now selected system number 7 and 11. Okay.
And also, here some peaks are there, right?
Mm.
So these are not belongs to this peak.
No.
So how we can consider that?
So you have to go to the 3D plane of this one and move it, and
Center.
whatever comes in the center,
Okay.
that is this. Okay. So you got it. So now like this you will have all the spectrum, all the spins and their 3D peak values. So you have to do it for all the spectrum.
If I want to strip,
Yeah, so if you do it for all the spectrum, you will so your data will be stored. When you go to spins systems, so I have selected for 11 and 7. In 11 it is everything is added, h and n values, h minus 1, hp minus 1 values are added. 7 also it is added. So I haven't selected for 3, but there is only h and n. If you add more spectrum and get CA, CB, CO, all this will be added to this. So finally you have to do a strip matching protocol. So you can open this spectrum, 3D spectrum in the strip scope. So in strip scope you will see the 7th you have assigned. Here you can adjust the contour parameter by CP. So 7 you have assigned, so it is coming. 11 also you have assigned, it's also coming. So if you have aligned full completely, then there will be. So you go to click on a spectrum. Sorry, click on a strip which is for the peak 7. Go to select strip and all best successes. Here we haven't aligned any, but if it is there,
automatically it will
then
come.
it will come. So after that, if you know the successor and predecessor, right click and sorry, click on this and show fragment assign to link spin system. So if you know, suppose 6 is predecessor and 7 is successor, you can assign it like this. Okay, so predecessor and successor will come. So finally one fragment you will get. So from the fragment, if you assign one, then remaining will be automatically assigned. Click on this any of the peak and show assign to. Assign to means some spin, this spin system 6 I'm assigning to 80th residue of my spectrum. Then it will come like 80, it will be assigned to 80 and 7 will be automatically assigned to 81 because they are connected.
Okay.
Suppose if you link the spin system, now you know 6 7 is predecessor is 6, sorry, predecessor is 3, successor is 6, then 3 will be assigned to 79.
Okay.
So like this you will get complete assignment. So here also, now if we go to systems, the assignments will be there.
Okay.
Okay. So now if you open the spectra, HSQC if you open in polyscope, after assigning completely, you will see. So these all are assigned.
Okay.
6 I have assigned to 81, 7 I have assigned to 81. So here I have E81.
Yes.
Right. Here I have assigned to 80.
Yes.
Now I have 79. So all this will be there.
Okay.
So you can view show list. Okay, you don't have to. Now you can export it to plain peaks to monoscope. That means you will get the assigned peaks in this monoscope. So this peak list you can export. export peak list. So this is your peak list, HSQC peak list. So this is the method for exporting HSQC peak list. Now if you want to get the export full assignments, then go to terminal or scripts. Here there is some script called write assignments. So execute the script, you'll get a window. There will be option output sent to terminal window. You make it to file. Okay, so yours will be str file. Okay, it is in BMRB format. You can change the format to Cyanide, Cara, anything. Okay, then will be in the folder. In your Cara folder, there will be an str file. Write assignments. So if you open, you can view your assignments.
Okay.
79 and 80 and 81 we assigned. That is there. Other we have not assigned. So whatever we assigned, it will become.
How to extract that image of the spectra?
Image of spectra means
Like PDF if I want to put assignment.
So I told you, like suppose you have spectra,
Okay.
open HSQC in monoscope.
Okay.
Okay. Now we previously have exported one peak list from here.
Yes.
So peaks, import peak list, HSQC peaks, open.
Okay.
Okay. Now if you want to export this as an image, file, print preview.
Okay.
You get here. So this colors and all you can change.
Okay.
Set positive color to be red.
Okay.
Set ruler color to be green.
Okay.
Set whatever. But things you can change.
Okay.
Okay. Then export PDF. That you can edit in Adobe Illustrator or something like that to get a good image.
Okay.
Print. So that will be wherever you can say. That's it.
Thank you. Done.